Good day and welcome to Nautel's NDB Systems for Offshore Markets webinar. I see we have attendees in various time zones, many in Southeast Asia, which is about 12 hours ahead of us. It's actually 9 p.m. for us here on the East Coast of North America. I'd like to take this opportunity to thank you all for taking some time out of your busy schedules to join us today. Participating in today's webinar from Nautel will be Richard Lee, who is our Asia Pacific Territory Sales Manager for our navigational products. Richard is based in Singapore, so it's now mid-morning for him. Also joining us today is Scott McLeod, who is a customer service technologist in our customer service team. Scott has many years of experience with offshore NDB systems, and he is based at our Canadian facility. And myself, Gary Galbraith, Sales Manager Navigation, also based at our Canadian facility. As was mentioned in the invitation for this webinar, our intention is that the information presented will benefit sales and marketing professionals, as well as field service and support personnel. Before we begin, just a point of housekeeping. For questions, we have a control panel here as part of the webinar. If you don't see the control panel, click on the orange arrow icon to expand it. And please enter your questions in the text box of the webinar control panel, and please remember to press send. So without further ado, I will ask Richard to begin.
Hi, good morning, everyone. My friends, everybody know that Nautel have somebody based in Singapore, the same time zone as you guys. So in the near future, if you have any immediate need or support, do contact me. I will do my best to support you guys. I will touch on the corporate history as well as the product range. For Nautel, everybody in this room is aware Nautel design, manufacture, sales, and support of navigational products, AM, FM broadcasting transmitter, industrial RF and communication products, as well as military defense sonar system. Nautel established in 1969. We have just celebrated our 50th anniversary last year. Nautel product is installed in over 177 countries. If you are not aware, the world have 195 countries, and we are in 177. Nautel have exceptional field reputation for reliable products. And Nautel has a dedicated team of long-term staff. Nautel also quality management system audit by BV, and we have certified for ISO 9001. Next, please. Nautel facility. Nautel Limited is based in Nova Scotia, Canada. This is our HQ. This is where we produce most of our broadcast transmitter. Next will be Nautel CTech, based in Ontario. This location is our production plant for all the sonars and defense equipments. Last but not least is Nautel Main, which everybody is aware and know of, is our US office that produce all the NDB and some range of broadcast transmitter. Nautel production capability. We have our CNC machine that we do fabrication of console, PWB, PCB assembly, light assembly, final assembly, final production test, as well as packing and shipment. We are doing everything in-house to provide to ensure the quality of our delivery. This is Nautel product family. As you may know, Nautel is the market leader for broadcast. So you can see our range of AM transmitter, FM transmitter, that is well known. In fact, everybody here, if you are driving to work every morning, you will listen to your radio. You are also a customer to Nautel broadcasting transmitter. Today, we will talk more on the NDB, so the navigation will be our focus. So in the navigation plan, we produce vector series of NDB, DGPS, and Navtex transmitter, and also the NDB, DGPS, Navtex ATU, antenna tuning unit. The next popular one is our E Lawrence range, as well as the LF antenna. Those who are interested in the others product range, like the Navtex, DGPS, E Lawrence, can contact us on a separate section. Next, we have the industrial RF, which we produce HF amplifier, LF com, weather radio transmitter, as well as the sonar system. Next, please. So today we concentrate on offshore NDB application. As everybody know, Nautel NDB has been deployed in most of the oil and gas rig, oil and gas platform, FPSO, and support vessel. Of course, not forgetting all the bigger vessel like cruise, LNG, whichever they need a helicopter landing navigation aids. Last year, we have entered into wind farm market. As everybody may know, wind farm market is booming in Asia Pacific. Many wind farm has been deployed in the Asia region, so there may be an opportunity for wind farm NDB deployment. So kindly look out for this business and contact us if you have any inquiry. Next. As I mentioned, we are in 177 countries. This is a map to show our worldwide navigation customer, whether you are all the base station customer, offshore NDB, or airport NDB. We serve worldwide. Now I will pass on to Gary to touch in depth into the NDB system.
Thank you, Richard. I'm just going to present a little NDB overview for those of you in the audience who may not be familiar with NDBs. You may be new to the market, just to give you some idea of what the product's used for and a little bit about it. So we'll start off with an overview slide, non-directional radio beacon, or as we like to call it in the industry, NDB. This equipment is used to guide helicopters to offshore platforms and vessels, and they operate in the low and medium wave frequency bands from 190 kilohertz to 1250 kilohertz and 1600 kilohertz to 1800 kilohertz. The transmission is AM or amplitude modulated, and that is transmission of the platform or vessel identification via keyed Morse code. So it uses, transmits Morse code, the ID of the platform or vessel. And they typically operate into a physically short antenna, so that would be a helideck antenna or a whip antenna, depending on the preference or requirements of the customer. This equipment needs to be highly reliable and require minimum maintenance. And the radiated signal from the NDB antenna is omnidirectional. So the signal strength is equal in all directions, and that's why it's called a non-directional radio beacon. So the pilot in the helicopter, he has in his cockpit what's known as an ADF receiver. And that is simply a frequency selectable receiver and an indicator. So the little graphic there shows a console with some frequency selected and also a little rotating needle. And this acts as a field strength meter with a direction finding needle. So the pilot would dial up the frequency of the NDB that he chooses to fly into. And at that point, the needle would point towards the strongest source of the selected frequency. So as the helicopter approaches the platform, the signal strength from the NDB antenna increases and the needle points towards the direction of the platform or vessel. And the pilot can also hear on his headset the ident code of the platform being keyed in Morse code. So here we have a block diagram of a typical NDB system. So we would have our NDB radio transmitter with an AC or optional DC supply. It would have a remote control and monitoring system connected. So that would be if we wanted to tie that into a network and be able to monitor the system at a remote location. We can also have extended control and monitoring. So if we had a location close by the transmitter that we would like to monitor from, we can also do that. The beacon would be connected via 50 ohm coax line to an antenna tuning unit, and the antenna tuning unit would be directly connected to the antenna. And some customers choose to also monitor the off-air transmission of the beacon. In that case, they would use a beacon monitor receiver and an active loop antenna. So the Nautel products that we offer to satisfy that application is our VR125, a 125 watt NDB transmitter. We have our ATU 500 SR-OS antenna tuning unit, and we offer the CLHD helideck antenna. For remote control and monitoring, we have the VR-Link 2 and ECMP3 extended control and monitoring panel. And we also have our NRB4 beacon monitor receiver and NLA2 active receiving loop antenna. So here's our block diagram again, and in this case, we've plugged in the various pieces of equipment that we offer. So you can see our transmitter with an AC supply, that could be from UPS. We also have a 24 or 48 volt DC operation option. Connected to that, we could have our VR-Link 2 remote control and monitoring unit, and that would supply an Ethernet connection to a remote site. And we also have an ECMP3 extended control and monitoring panel for simple remote control and monitoring. The transmitter would be connected to the ATU 500 by the 50 ohm coax. There's also a 24 volt DC supply line that's connected between the transmitter and the ATU to supply the ATU. And we have a serial bus for communications between the transmitter and the ATU. The ATU would then be connected directly to the helideck antenna, and the transmitted signal from the helideck antenna could be picked up by the helicopters, but it can also be monitored and received by the NLA2 active loop antenna, which would be connected to the NRB4 beacon monitor receiver. So for remote control monitoring, I mentioned we have a serial bus connecting the transmitter and ATU. And one of the features of that serial bus is it allows a technician to control and monitor the ATU from the transmitter where the RF field is well below unsafe levels. So if the beacon's operating, we don't want to have somebody working at the ATU in the near field of the antenna. So using this feature, it's possible to control and monitor the ATU from the transmitter. We can also try our transmitter into a comms network, which may be located offshore, remote to the platform or the vessel. And so technicians can also control and monitor from this remote location and do diagnostics. And this will reduce costly visits to the NDB site. The NDB transmitter is available in single configuration, field upgradable from single to a dual, or in dual main standby configurations. The standard NDB carrier frequency band, as I mentioned, is 190 kilohertz to 535 kilohertz. We also offer an extended band, 536 kilohertz to 1250 kilohertz and 1600 kilohertz to 1800 kilohertz. The standard emission modes from the NDB is NON, A2A, and A2A, A3E. Built-in diagnostics to the transmitter allows the user to easily identify faults to the lowest repairable unit, and that can be done locally at the transmitter or remotely via the remote control unit. So rather than have to go to the transmitter to check it out, you can do that via the remote control unit. And another nice feature is the non-operating side of the transmitter, or the side that's not on the air, can be tested locally or remotely without the need for dummy load while the main side remains transmitting on the air. That's a very nice feature. And as I mentioned, we have enhanced remote control and monitoring to extended and remote control monitoring locations. On the front panel of the transmitter, we have a graphical user interface and display, which contains an analog meter, and that can be configured to display a number of parameters from the transmitter: forward power, reflected power, antenna current, modulation percentage, various DC voltages, DC current, and other important parameters of the transmitter. There's also a system diagram, which gives you a block diagram representation of what's happening within each module of the transmitter. And within each block, there's a little LED which will light red if there's a problem with one of the functional blocks. And there's also a diagnostic LCD display, which allows for complete control of the transmitter and ATU status, local and remote health monitoring, digital metering, and a 256 event log. And the event log is very nice. It will capture events, alarms, status indications, and you will be able to either locally or remotely scroll through the event log to see what has happened in the event of a failure. So for reliability, repair time, and warranty, the reliability, the MTBF has been calculated to be greater than or equal to 12,590 hours for a single transmitter and 17,640 hours for a dual transmitter. Repair time, mean time to repair, is less than or equal to 1/2 hour at the PWB module level. So very quick to bring it back on the air if there's a fault. And our warranty is 36 months from date of shipment. Our warranty used to be 24 months, but we polled a number of our customers in the offshore, and they were really interested in us increasing that warranty. We knew we had a reliable product, and so moving that up to 36 months from date of shipment was not really a concern for us. We have various compliances for our system. Designed to comply with Safety Code 6, of course, industry standard, Industry Canada, ICAO Annex 10, RT and TTE or EC, compliant with EN 6215 safety requirements for radio transmitting equipment, and of course we have Nautel, Serum, Postal, and FCC. So we're going to talk a little bit about installation for those of you attending who might be involved in installation and support of the equipment. So I'm going to hand the presentation over to Scott McLeod, who is very familiar with this equipment. Scott, so I'll pass that over to you to discuss installation.
Good morning or good evening, everybody. Yeah, so I'll just go through the presentation we have here, and we'll talk about the installation and the connections you have to make to the different Nautel components. What we're looking at here is a picture of the VR125, which is the transmitter itself. It is not located in the rack at this point. A Let's go to the next slide, Gary, and we'll look at the connections we have to make to it. So from the back, the two minimum connections we need to make to get the transmitter to work is the AC input, which is located on the bottom left. The supply can be 125 to 230 volts. Doesn't matter. There's no transformer adjustment inside. It's all switching power supplies. So as long as your supply is 230 to 115, I think the power supply range is actually 90 to, for the low power 125, it's 90 up to 275 volts AC in. And there's a 5 amp breaker on the back of the transmitter. And then the RF output, which is a 50 ohm end connector output that we're going to terminate to our ATU or our antenna system. And those are the minimum requirements we need to connect to the transmitter, and it'll run. Okay, so here we have the back panel removed from the transmitter. It's important to note this, especially for offshore, because typically when we sell a transmitter for offshore, the frequency is not known. And also, if you sell one in the shipyard and it gets installed, they'll test it at one frequency, and then eventually it'll go off to its site, and they may have to change frequency. So one thing to keep in mind for installers is the frequency. Now, the transmitter is capable of running typically from 190 to 650 kilohertz, but there are a couple small adjustments we have to make. So if we did not know the frequency at time of shipment, you're going to have to open the back panel here, and you're going to access the filter and just look at the links inside. And the panel that we remove actually has a table on the inside of it that tells you what links to make for what connector. And it's all quick disconnect, so no tools are required other than to take the panel off. So that sets up the filter for the frequency range we want to work at. Okay. This shows the front of the transmitter and the front door. It's the front panel that has the overlay and the buttons that Gary showed you is on a hinged panel. So you just use a flathead screwdriver to open the mechanism, and the door hinges open, and this is on the inside. The other connections that we show here are for remote control, which is it can be an RS-232 or 422 connection, which is serial information from the transmitter that is designed to interface with a VR link, which allows the web-based remote control. The other connection is the ATU serial comms, which is not required. The transmitter and ATU will both work without the ATU serial comms connected, but it does provide the benefit, like Gary said, if you have an ATU 500 and you have the serial comms connected, you can monitor the ATU from the transmitter, and you can actually slew servo probes and make sure they auto tune. So you can do maintenance with the system on air in the safe environment without the RF field at the transmitter. The other board here, which is an optional site interface, would be used if you were going to use a ECMP3 remote IO type close contact connections to control and monitor the transmitter. So if you weren't using a VR link, you could use the site interface, which could be used with our ECMP panel, which is just basically lights and switches to control and monitor the transmitter remotely, or some other external panel that runs off remote IO contacts. And these the cables all feed through the front to the back of the transmitter and then out the back. The other connection that we do have to make if we're using an ATU 500 is we have to supply the DC power to the ATU 500 so that the coils and mechanisms can move. And that's on the bottom right, with just a 24 volt current limited 1 amp power supply from the transmitter to the ATU. The synthesizer boards are the other component that you have to check as part of your frequency change or installation. You want to make sure the system is set at the right frequency, and there are, in this picture we show dual exciters. So we have two synthesizer boards, main and a standby, and each synthesizer board has 5 BCD switches which set up our carrier frequency anywhere from 190 kilohertz up to 1.8 megahertz. Okay. So this is showing one of the cabinet options for the transmitter. This is a fairly common one in for offshore use. It's an IP66 cabinet. So it's a fairly small rack and it's weather tight. So it's designed so that you can install it out at the transmitter or out at the ATU if that's where you're planning on installing the transmitter. The IP66 transmitter has liquid tight cable glands that you can see along the bottom and up the side. So these are cable glands. They got a little rubber washer inside, so you can feed in one cable and then tighten it up, and it squishes and makes it liquid tight. But you can only feed one cable of the proper diameter through each cable gland. So at minimum, of course, with the VR125, you're going to want to connect AC if you're running on AC power, and you're going to want to have DC out to the ATU. And sometimes this is on a separate cable to the serial comms, so you might want the ATU serial comms out as well. So that's 3 cable glands you'll want to use, possibly 2 if the DC to the power supply to the ATU is on the same cable as the serial comms. And then you have the RF input, which does not go through the cable gland. It goes through a liquid tight end connector that is on the bottom right of the IP66 cabinet. The cable glands that are not used have a plug in them, so you will leave the plugs in. And there's a rubber seal around. In the left-hand picture, you'll see that little black neoprene cord. So that is a cord that when you push the front cover on, it makes it liquid tight. Okay. So on the left-hand picture here, one thing you can see is the slides. So there's one slide on the left and right-hand side of the cabinet, and that's what the transmitter is physically mounted on. So if you do buy the transmitter with the IP66 cabinet, you can physically pull out the transmitter from the IP66 cabinet, which allows you access to the rear to check the settings on the filter board and allows you to pull out power modules and to maintain the equipment without having to physically remove it and disconnect it from the IP66 cabinet. On the right-hand side, you see the AC terminal blocks where you would terminate your AC input wire, which would then connects to the transmitter with internal wiring. And if there was a DC option as well, there'd be more wiring in there, and you'd run a DC power source into the terminal block, which would then terminate to the transmitter as well. And that's an option. Okay. So that's the transmitter installation. Now the ATU 500 installation is extremely easy. There's not a lot of inputs and outputs to it. We'll first talk a little bit about the mechanisms of it. So this is the ATU 500 with the front cover removed, and it has the optional sun shield that you can see sort of on the top, which looks like, you know, just a little shield or an umbrella, help keep the sun off it and keep it cool. There's a spark gap, which is located on the top left, which is the, there's a stud, it's a little bar that's on the RF output, and then there's a acorn nut that you push in towards it to set the proper spark gap to protect from lightning strikes. But for offshore, that's typically not really important because your boat itself is there's things that are typically higher than the beacon antenna to get hit before. So there's 2 coils that move up and down, which is the auto tuning element of the transmitter. So if your antenna impedance changes from maybe some salt buildup on the insulators or icing, not if it's in Singapore, but depending on where it's going, icing on the antenna can change the capacity slightly, or even just things moving around, different cranes on the rigs moving closer or farther away from the antenna. These coils will maintain the tune of the transmitter. Once again, this is also an IP66 rated cabinet. It has the neoprene cord around the edge that the cover sort of pushes in on, and it's just secured with the cover is just secured with Phillips head screws. There are some on the right-hand side. You'll see some resistors. They're little gold and they're heat synced to the chassis. They're just there if you need to add more bandwidth. And you can certainly see some tuning videos on the Nautel website. We'll discuss why you'd want to add them, but it's basically you would just add them if you couldn't get the modulation depth because your antenna was too electrically short. But typically with the ATU 500, that is not a problem. The coils typically have enough resistance. You do not have to add more, especially if your modulation frequency is 400 Hertz and not 1020. Okay. So here are the connections that we would make to the ATU 500. The ground stud is on the other side. Here we have the N connector, which is the 50 ohm input from the transmitter. So that's our RF power. And then there's two cable glands. You need one for the DC connection. And then if your DC connection is not the same cable that has your serial comms, you'll use the other cable gland as well. So possibly two cables feeding in, possibly one, depending if the DC and serial comms are on the same cable. The mounting bracket that you see there, there's 4 mounting brackets, 2 on each side, and they can be located in 2 positions. Here, that's located for like a wall mount, so you'd mount it on something on the wall, but you can also move them and mount them on the base so that you can have it sitting on something. And you just do it by moving the brackets to the floor facing down, and there's holes there. Okay, and I'll just mention all because it's IP66, every screw or bolt that goes through the cabinet does have a sealing washer, which is like a stainless steel washer with a rubber insert that compresses it and makes it liquid tight, just like the IP66 transmitter cabinet. Okay. And the connections inside, once we bring the cables in, the RF cable terminates to an N connector on the outside. The serial comms and 24 volts from the transmitter terminate on a terminal block on the small serial interface board on the left-hand side. You see it on the bottom left-hand side. All the connections will be on a little terminal block. You just need a small flathead screwdriver, and it's just compression fit. You put in your wire and tighten it up. Okay. Here is the other side of the ATU where we see the RF output. Keep in mind the RF output potentially has thousands of peak volts on it. So you want to make sure your connection from the RF output of the ATU to the antenna is electrically short and cannot connect to ground. You don't want to take like some sort of 8-gauge shielded wire and tie wrap it around the railing of your ship. It'll just arc through because there's too many volts there. It's in the middle of a tuned circuit. And then the ATU itself has to be grounded. It's just like any circuit. You need an output and a return, and the return is coming through the ground stud on the bottom side, and you're going to connect that for offshore to your vessel. So, make sure it's on. You scratch the paint off a surface, and then you bolt it down, just with typically a fairly big gauge wire. Okay. Now, certainly we have a lot of remote control options. Gary, did you want to talk about this, or do you want me to carry on?
If you wouldn't mind, Scott, maybe you could carry on.
So there are certainly a lot of remote control options. We have the VR link, which is it communicates serially with the transmitter and then allows us to use a web-based page to look at the transmitter. And the benefit of that, of course, it's on IP, so you can access it anywhere as long as it's connected to a network and you have access to that network. And you'll see the VR link on the left-hand side there. The ECMP3 has 2 functions. It can work with the VR link and communicate serially with the VR link, or you can use it just as a remote IO function and connect it to a site interface board if you're not using the VR link option. And then for the on-air monitor, you use the combination NRB4, which is basically like a tuned AM receiver basically, and the loop antenna, the NLA2. And the NLA2 receives the on-air signal. It's just an antenna. It's receiving your broadcast and feeds that broadcast down to the receiver, which then indicates the power level based on 0 dB, which is we set up for normal, and we set it up for alarms of low modulation and load carrier. And we'll talk about how to connect these things up in a second. Okay, Gary. So the extended control panel, which we see here, we can connect it through 152 meters directly to the transmitter if we're using remote I/O. There are 7 lights, which can be, we have them labeled as the Nautel typical setup, but you can set it up. It is very flexible. You can set up the lights for any number of things. These are just how Nautel by default documents how to install it and set it up. So there are 7 lights. There's a total of 3 switches, 2 that are configured for the remote on-off and a timer on-off. And then there's 1 spare that we don't recommend how to install. It's just a spare switch. But like I say, it's really flexible. You can set it up however you want. You're just going to want to make sure you relabel the lights and switches depending on how you set it up. But I think we've picked, like, I think the way we document it is like the optimum way. So if you're going to ask me in customer service, how should you configure your ECMP3 with the transmitter, I would go exactly through the book and say, here's how you should connect your ECMP3 to your site interface port. Okay. Now, the other way we can use the ECMP3 is to connect it to the VR link. This shows it to the site interface board. Right, so this just shows the connection that we're talking about. You're gonna have some series of connections that are gonna connect to the site interface board, which allows for 16 monitor points and 16 outputs. And if you have it set up like we have documented, you'll have RF on off, timer on off, and then you'll have statuses of low AC, standby side, changeover, shutdown, and those alarms. And you connect it just with screw terminals. On the site interface side, it'll be a terminal block. And on the ECMP3 side, you would connect it to a D-sub connector that you would solder wires to. And the D-sub is part of the ECMP3 ancillary kit. So you would just have to bring the wire and solder it to the D-sub that's in the ancillary kit. Okay. So this just shows the ECMP3 and on the other side. There's a jumper to affect the light brightness setting, and there is a volume setting for the Son Alert, which is the blue device you see there. That is set up with there's switches on the site interface on the ECMP3, that set up what alarms will trip that Son Alert. So right now, any of those, if any alarm happens, so low AC, changeover, shutdown, or comms errors, you're going to get this from the Son Alert. And then when you hit the acknowledge button, it will kill the audio sound. And you can disable the audible by just setting the dip switches that are physically on that green board. It's kind of hard to see now, but they're 2 little dip switches, set of dip switches, sorry. Okay. And this just shows the DC supply is just a bought out supply that you can plug in, it powers it up. The serial data, if you were connecting to a VR link, then you would use the terminal, that green terminal block, and use 485 connection. If you're connecting it through the site interface board to the transmitter, then you would use the D-sub connectors shown, the parallel wiring there. Okay. Now this shows the VR link with an ECMP3 installed in it. So the VR link can come with an ECMP or just a blank panel there. So if the VR link is going, if you're installing it at the transmitter, you don't need an ECMP3 because you're physically at the transmitter. If your VR link is being installed away in a room that you also want to have control, then you should have a local ECMP to it as well. It's an economical means of remote control monitor of the transmitter. It connects to the transmitter either through an RS-232 or 422 connection. So the transmitter physically has a 232 connection and a 422 connection. Which one you connect is up to you. And there's different connections on the back of the VR link depending on what you're connecting. If you have the transmitter serially connected to the ATU from the VR link and from the web, you can see the status of the transmitter and the ATU. And like I said, this picture shows the ECMP3 being integrated into the VR link. And then you have an option on the VR link. You can have 3 other extended control panels in different rooms. So you could actually have a total of 4 ECMPs working in parallel in different rooms controlling the transmitter. And they are in parallel. So if someone turned it on in room A and then someone went to room B and turned it off, it would turn off and then room A would have to turn it on again. But you could have up to 4 locations of the ECMP. Okay. This shows the web interface of the VR link. So the VR link is speaking to the vector transmitter, and it's hosting a web page with an IP address that we, the user, will set, whatever we want for an IP address. And then we can take our computer and just open up Internet Explorer or Google Chrome and type in the IP address of our VR link, and then bang, we'll get a web page like this. And the VR link is really flexible. We don't talk about many of the features here, but we can see all the status and controls. There are different user accounts. So anyone who has the IP address can look at it, but they can't control it unless they log in. And there's different credentials for login and users. But you can get logs from here, all the meter readings and the current status. Okay. So VR 125 to VR link connection. So all we need from the VR link to the transmitter is a transparent either RS-232 or 422 connection. There are several different options. There are actually built-in option with the VR link if you want to have a modem. We can install the modem, or if you had your own external modem, as long as the VR link to vector sees a transparent RS-232 or 422 connection, it doesn't matter. I've had people use fiber optic connections between, they'd have the transmitter use fiber op to the next converter that changes it to 232 again, then in the VR link. So as long as it's transparent 232, it's great, but there is options for a built-in modem option if that's what you want. If you want it done at Nautel and then want to feed in a leased line type connection for control. Of course, the connections are limited in length, 15 meters for RS-232 and 1 kilometer for 422. Wow, that's long. I wouldn't have guessed that, but so for 422, you can get more distance. So depending on how far away the VR link is from your transmitter will dictate the type of connection you may have to use. Okay. So once again, the remote control systems, we got the VR Link 2 with the ECMP3. So here we have a couple of ECMP3s connected to the VR Link. So we can control the transmitter from 2 extended remote control panels. One is physically part of the VR Link and one is in some other room, and it's connected with 485, which is certainly can be run long distance up to 1 kilometer. Then you connect your VR Link either through a direct to a PC, or you can connect it to a network and then connect as many PCs as you want to the transmitter over your network. Okay. And this just shows the front version of the VR Link. And in this picture, there is no ECMP3 connected to it. So this VR Link is just connecting serially to the transmitter, and then we have to connect to it over IP to control. There is no ECMP built in. Now we could have some external ones connected to these 3, you'll see the 3 green connectors in the middle. Those are connections for ECMP 1, 2, and 3 that can be in different rooms up to 1 kilometer away. To the left of those, you'll see the RS-232, thanks Gary, the RS-232 and 422 connections. You would connect one of these to the transmitter. That's how it's getting its serial data. And then you have to power up the unit because it needs some power supplies. So you can feed in your 90 to 230 volts into the AC connection at the bottom. Or if you have a DC option, you can connect it to 24 volts DC through the connector at the top. Okay. And then there are a total of 3. So every VR link will come with 3 RJ45 type connectors on them. 2 will be labeled LAN, 1 in the front, 1 in the back, and 1 will be labeled WAN. Only one of them will be terminated, and I believe it's the one in the back that'll be terminated. So you'll connect your network to the LAN connection, which is right here in the back. And you can actually see if you have the VR link connected RS-232 or 422 to the vector transmitter. At the vector transmitter, you can actually see the IP address settings of the VR link. So if it's set for DHCP or if it has an IP address. And you can set the IP address from the VR link. And then you can connect it to your network knowing what the IP address is. There are different options for the VR link so that there's a single board computer option, which allows you to connect the WAN and it will actually assign IP addresses and stuff, but that's an option. Okay. Oh, sorry, I talked about this earlier, but those 3 circled connectors, that's where you would connect RS-485 to the 3 ECMP3s if you wanted. So each of those green connectors there connects to 1 ECMP3. And you just connect 1, 2, or up to 3. When you are connecting them, just a note, make sure you turn the transmitter VR link AC power on and connect one. Then you can connect the other, and then you can connect the other. Don't grab 3 ECMP3s and plug them in all at once and power on. Unless it was purchased, then it will be set up properly. Okay. So this just shows one scenario of connecting up the transmitter. We have a 232 connection to our VR link, and then we have a VR link with an internal ECMP3. So we have the VR link with the switches on it so we can control it in a different room than the transmitter. And then we have a connection from the VR link up to the heli tower so that we can control the transmitter from the heli tower as well, as long as the transmitter is in remote mode. If it's in local mode, you won't be able to control it. You'll only be able to monitor. And then from the VR link, we have a IP connection to our internal network. And then from our internal network, we can go to PCs or route it to the outside world, the web. Okay. So that was the remote control part so that you can connect. There certainly have a lot of options. There are some videos that you can see online at Nautel Nav for setting up the transmitter and using the VR link. So if you have any questions, one thing you can look at is those videos on the Nautel Nav website. They're pretty good. And this is the on-air monitor, the receiver, the NRB4. It works in conjunction with the NLA2 antenna. Once set up, it'll give you alarms if carrier is dropped by more than 3 dB, if the modulation is dropped by 4 dB, or if the key tone is stopped and we're getting constant modulation, and you will get a light and a alarm, a audible to indicate that there's a problem. Okay. At the back of the NRB4, there is access for more remote connections. If you had another remote panel, not ECMP3, this is a different type of panel, but you could connect another panel just to monitor the on-air detection in a different room so that you can see the NRB4 gives you normally open or normally closed relays, and they toggle if you get a carrier or modulation fault. And you can also get the audio that you can hear the ident through the front of the transmitter. You can get that audio out and connect it to an external speaker if you want. And the two requirements for connecting that you must have for the NRB4 is the AC input, which you see on the right-hand side, which is just an AC line cord, 9 and 275 volts. Well, actually, I think it's there's two versions. There's 115 or a 230 volt option. And then the end connector, which is the connection you're going to make to your loop antenna, which is located outside where it has a view of the antenna. Okay. And this is the loop antenna. It's only got one connection, which is the end cable from the receiver. The receiver phantom feeds 12 volts into the loop antenna to activate it. It's an active antenna. So there is 12 volts on the cable that you're going to plug into here. So make sure you don't short it. And the loop antenna works. There are 4 screws that hold that top orange plate down. You will have to access that once to set frequency, which is shown here. There's just a few jumpers that you have to make depending on your frequency. Once again, typically for offshore, we don't know the frequency at final destination. So you will have to go in and make sure the jumpers are set. Otherwise, it will not receive the signal. And it's just tin copper wire. It's a solder terminal for these. And there's 1 to 3 links, I think, depending on your frequency. But it's pretty easy. There's not much to it. And it comes with an ancillary kit that allows you to mount this to a railing. Okay.
Thank you, Scott. That was very good, useful information. And we're going to talk a little bit about offshore NDB antennas now. We offer the CLHD helideck long wire antenna, and that's designed to suit a variety of helideck configurations. Here we have an octagonal helideck arrangement, but it could be used with different arrangements. It's designed for compliance to CAP 437, assuming that it's installed correctly. And it's a broadband antenna, so it will operate from 190 kilohertz to 1800 kilohertz. And the capacitance of this antenna is approximately 3 picofarads per foot or 9.8 picofarads per meter. Some customers prefer a helideck style antenna, but some customers might prefer to use a whip antenna. And in this particular case, what we have illustrated there is the Comrod AS1R. And that is an 8 meter or 27 foot high whip antenna, relatively low cost, easier to install than a helideck antenna, and also frequency agile. I guess one downside to a whip antenna, depending on where you locate it, is it does present an obstruction to an incoming helicopter. So you would want to make sure that you locate it, some distance from the helideck, so as to not interfere with the helicopter landings. Just a little bit about our customer service and training options. We offer emergency technical support 24 hours a day, 7 days a week, and that's provided by our Nautel customer service technical staff. Our facilities house a full inventory of parts, modules, and subassemblies to support customers' maintenance needs. So if you need a spare part, you can just contact our customer service department directly, and they will look after you. And as the slide says, our first priority is getting customers back on the air, even if the model in question was shipped in 1970. So we haven't officially ever discontinued support on any product that we've ever sold. It may be difficult for us to source parts, or it may be that the system is so old that the parts are no longer available, but we will at least make an attempt to find the component that you're looking for. We also offer RF basics and system-specific training and certified installer maintainer programs. That's been a bit of a challenge recently with the COVID-19 pandemic, but we're looking at presenting some of this material remotely via MS Teams or other such web-based transmission systems. And the Nautel advantage, we would like to think that we have some advantage, very good advantages for our customers. We have 50+ years of excellence in RF design, manufacturing, and support. Our systems are very cost competitive, highly reliable. I mentioned our 3-year warranty that we have now. We have over 40 staff in our engineering and customer service teams to assist. And we have multiple facilities to ensure uninterrupted supply of equipment and spare parts. So for contacts, there would be myself. Here's my contact information, my email address, and a couple of phone numbers, my office phone and my mobile, and also contact information for Richard, email address and his telephone number and his Skype address. So if there's anything we can do to help you out, if you have any questions after the webinar, please get in touch with Richard or myself, and we'd be happy to assist. So do we have any questions from our attendees? We have a few minutes left. So if there was any questions there, I didn't see any come in during the webinar, but if there's anything, any questions, we'd be happy to receive them.
Yes, anyone have any question regarding the product, the business, the technical part of it, do post us a question on this chat on the question area.
I see a question here.
So if you hit the questions, Gary, you can see that I see looks like there's 1, 2, 3, 4 questions. So one of the ones Vincent asked, did not see any dummy load in ATU. The ATU does not use a dummy load. It doesn't require a dummy load. You could purchase an ATU antenna simulator, and then you could run the ATU the ATU into the antenna simulator instead of an antenna to test it. But there is no internal 50 ohm load or anything like that inside the ATU. Dual power feeder option available in the TX. The VR125 is a single AC input that then would go to, if you had a dual transmitter, it would go to dual low voltage power supplies as well as dual power modules, and there would be dual exciters, but the input itself would be a single AC input. Although there is the option for a DC power option. So if your dual power option feeder option in the TX is regard to AC and DC, then yes, you can buy a DC option to power up the complete transmitter if AC fails. But if you're running off AC in the Vector 125, it is a single AC feed that gets split to the dual components, which are power supplies and power modules and exciters.
I think there's a question. There's a question mentioned that many countries planning to decom the NDB. Is yes and no. There are many people, many offshore is going downturn, so they probably decom those. But the operation wise, as long as you still have the helicopter support, NDB is still needed. So we are still providing a lot of offshore industry with NDB, as well as all the airports. Gary, there's a question asking about the cable length for the antenna.
Yes, the standard length that we supply for the CLHD antenna is 300 feet.
Right, and you don't need to use the whole 300 feet, but certainly the more cable you use, the greater the capacity of the antenna, the better the radiator would be. But you'll be limited by the you know, geometry of your system.
Someone asked, can I have the presentation slide? This video will be recorded and will be posted on our website. And after the webinar, we will be sending you a link to access this video so that you can share with your internal company or your technical staff, etc.
Yes, the webinar will be available in the resources section of the Nautel Nav website.
So I'm not sure about the Vincent's first question, HTTP or HTTPS. I know I access it through the internet. I don't know, but if you email support or Gary that question, we can certainly dive into it. Unless Gary, do you know? I'm not even sure I understand.
No, I'd have to dig a little deeper on that one.
So sorry, I don't know. So Vincent, if you send an email to info@nautel.com or support@nautel.com, we will dig into it. And you can reference my name if you're sending it to support. Just send it, ask it to be addressed to Scott McLeod or Scott, that's fine. How far can the monitor receiver be able to detect the NDB signal? Wow, great question and a tough question. So it's a receiving antenna. So yes, a kilometer, once again, it all depends. So if you're broadcasting offshore and you have a receiver onshore, you should be able to pick it up, I would think, as long as you're running at a decent power. It's all in the range. I think we tested down to, I can't remember in the test procedure how many microvolts, but we tested at a very low level. So it really, the range all depends on how strong the field is. And that depends on your antenna and what you're broadcasting over and how much power you're putting into your antenna. So it's not an easy question where you can just say every NRB4 and loop antenna will be able to receive it at a kilometer. For offshore, I would expect it, but as long as your antenna is, you know, if you're using 6 meters of antenna wire, that's not going to be a great antenna. I would say typically you're going to use more than that. And if you use a whip antenna, I would expect you'd be able to receive it a kilometer. But then if you're going through, you know, if you're further back inland where the range is going to be eaten up by, depending on your ground resistance, then maybe not. So it's a tough question to answer. I can't give you a definite yes or no. It all depends on power, antenna, and what you're broadcasting over.
So there's a question asking what is the maximum power of our NDB? Can I say, Gary, can I say that the maximum is 250 watt or we can put in more?
For offshore applications, typically we offer the VR125, which is 125 watts. We do offer a 250 watt NDB, but we also offer higher power levels, which are typically used for land-based applications for airports or en route aircraft. So we do a 500 watt, a 1 kilowatt, and a 2 kilowatt NDB as well. But again, those would typically be used for land-based applications.
Anyone have any more questions for us to pick? Maybe a last question, anyone?
Okay, well, I think we've run a little bit over our hour, but that was good. Thank you very much for your questions. Those were great questions. And I'd like to thank you all again for joining us. And we hope that you found the information presented to be beneficial to you and your business. And I'd like to wish you all have a great day. Thank you.
Thank you very much. Keep in touch.
Bye, everybody.